Hello everyone, welcome to Lessons with Philip. And today we want to go further to the perimeter of a segment. Now in our previous classes I've explained what a segment is all about. Okay, now we have a question on the board. If you check this question we have on the board, this diagram, what we have, all this one is known as segment. And I told us that a segment comprises of an arc. Okay, this arc, this line, which is an arc SY, and the chord SY. So this total, if it has the perimeter is the distance along the total surface along the shape. Okay, now that shows, I've told us that a segment consists of chord and arc. So automatically, if you know this, you understand that the formula of a segment, now, if it has to find a segment, now the formula of a segment will not be equivalent. Don't forget, this is my chord. My chord XY, that's the chord is what? Our formula to find chord is 2 radius, 2 radius sine theta divided by 2 plus my arc. The formula to calculate my arc is same thing as theta over 360 multiplied by 2 pi r. Okay? Now, some people can decide to use, instead of 2r, you can use diameter. If you're given diameter, sine theta divided by 2 plus theta over 360 multiplied by times diameter, pi times diameter. That is if you are given diameter. This is our fifth formula. This is number 5 that you need to take note. Now, in this case, we are given the diagram and we have to find the perimeter. Don't forget, there is difference between a perimeter and an area. Okay, now we're dealing with perimeter of a segment. Later on our classes, we'll deal with areas of a segment. Now, let's go. Now we have to find the segment of this circle, the minor segment. Okay, this one I've painted is the minor. The one up here is the major. If it has to find the major, it's the same way. Okay, that shows you find this segment, but the angle will be different. This angle is the one that's subtended. It is the one that is subtended by the arc, this minor arc. So you have to use the major angle that suspend the major and the major arc. Okay, now let's go. Perimeter of a segment. This perimeter of a segment, I've told us the perimeter of a segment, perimeter of a segment is given as this formula. Now perimeter of the minor segment is now equivalent to what is, I've been given my radius to be 8 centimeters. That shows I have 2 times my radius, which is 8, times my sine, What is my theta? My angle subtended by the arc is 60 degrees. That is 60 degrees divided by 2 plus my theta is still 60 degrees. 60 degrees divided by 360 degrees multiplied by 2 times, always take your pi. If you are not given, if you are given, you can use 20 over 7. Okay, if you're not given, it is 3.142. Either you use this or 3.142. Okay, it's a constant. Okay, multiplied by, I want to use 22 over 7 multiplied by my radius. My radius is what? Is 8 centimeters. Okay, next thing is to use my calculator or multiply where necessary. So this is now equivalent to, so 2 times 8 is 16. I have, this is equivalent to 16 sine 60 divided by 2 is 30 degree. 30 degree plus, okay, 60 year 1, 60 year 6. Okay, 2 year 1, 2 here 3. So I have 22 times 8 divided by 3 times 7. 22 times 8. So I have 22 times 8. Let's use our calculator. 22 times 8 will give me 176. So I have plus 176 divided by 7 times 3, which is 21. And that will be equivalent to 16 times sine 30 degree. Sine 30 degree is half. That is times half plus 176. 176 divided by 21. Divided by 21 will give me 8.381. Okay? Now, this is the same thing as 8 plus 8.83, sorry, 8.381. And that's equivalent to 16.381 centimeter. And that is the perimeter of the segment. Okay? If it is the major segment I'm asked to find, I'll use the same method for the major segment to calculate the perimeter of the major segment. If I want to calculate the major segment, it's still the same formula for the segment. Okay? But the only thing is my theta will change. Okay? The angle subtended by the arc, this arc, will now be what? 300. How did I get my 300? I've said angle subtended in a circle is 360 degrees. Sum of angle in a circle is 360 degrees. That shows if this place to this place is 60, the rest will be 300. Okay, now for the major segment, that will be my theta, my radius is still my radius, which is my 8 centimeter. We have 2 times 8 sine 60, sine, my theta is what? 300. Sine 300 degree divided by 2 plus my theta is what? 300 plus 300 divided by 360 degree multiplied by 2 times 22 over 7 times what? R, which is what? My 8 times 8. So 2 times 8 is 16. So we have 16 sine 300 divided by 2 is 150. That's sine 150 degree. Okay, plus 300. If you calculate this, 0 will cancel 0. Okay, 3 here 10. 3 in this one is 12. Okay, 2 here 1. 2 here 6. Okay, what again? 2 can still go. 2 here 3. 2 here 4. What are we left with? We are left with 10, 22, 4, and 3 and 7. So that is 22 times 4. We have 22 times 4, okay, times 10. That is 800. We have, 880. That will be 880. We have 880 divided by 21. And that's equivalent to 16 sine 150. My sine 150 is now equivalent to times 0.5, that is half, plus if you divide 880 divided by 21, you get 41.905. And that is equals to 16 times, this is 8 plus 41.905, and that's equals to 49.905. 0.905 centimeter. And that is our final answer. This will be the perimeter of the major segment. If it is perimeter of the major segment, this is what they ask us to calculate. This length, just follow me. This, like this. This is what we are trying to calculate. The total surface of this segment. That is what makes 49.901 or 49.91 centimeter to 4 significant figure. Okay? Now, if you find this class very helpful, now coming class, we're going to deal with the perimeter of a sector. We're going to deal with sector. Okay? Kindly follow my class. Subscribe to my channel. Thank you so much. Bye.